All right. Good afternoon. Welcome to today's lectures. So we are going to continue with our lectures. So the way it is going to be today is that once we are done with today's lectures, then we are going to go back, starting with the first slide, and then you'll be asking questions where you didn't understand. All right, that is what we're going to do today. Okay, so we are going to continue looking at module 2, and then from there we are going to do 2 slides which are in module 3. Okay, so we are continuing where we left off yesterday. Okay, so this is our topic: common server types and threats. Forward, in a broad sense, a server is a computer system that provides services to other machines over a network. More specifically, a server is a high-performance computer that provides business services to external computers through a network. Therefore, servers require higher stability, secure, and performance than common PCs. So a server is a computer system, but the difference between the PC and the server is that a server must be more stable, it must be more secured, and of course it has a higher performance than PCs. That is the only difference. So a server has to handle so many different types of services, and it has to serve so many users. Objectives. Upon completion of this course, you'll be able to describe categories of servers, functions of common servers, security threats to common servers, and then vulnerabilities and patches. So of course, anyway, we're going to look at vulnerabilities and what are they. Contents. So this is what we're going to look at today. So we'll start with server overview. Okay, so what is a server? A server is a high-performance computer that provides services, including query, storage, computing to clients over a network. Okay, so the clients here, these are the PCs, the laptops, the smartphones. All right, so what they are doing is they are asking for services from the server, and the server has to provide the services. Okay, so a server mainly provides services such as web applications, file download, database storage, as well as printing. So this is a network here. These are what we call the clients. And then here we have different types of servers. Okay, so this is the email server here. This one here is the file server, and then this one is the database server, and then we have got the server here which offers printing services. Okay, so the clients always, they ask from the server, and the server has to provide that information. Okay, right. Features of a server. So this is the internal structure of a server. This is how the server looks like internally. Okay. So the first feature is availability. A server must be available always. A server has to run 24/7. Okay. And then a server must be usable, usability. So a server here, it serves so many users. Okay. And then scalability is another feature. So since a server handles a large amount of people, therefore it must be scalable. That is, a server must have additional slots where you can put in more RAM. Okay, and also additional space where maybe you can add more disks. Okay, that is scalable. Okay, so if you have more services, then you have to increase the size of the RAM. You have to increase the size of the disk. So that is scalability. Okay. And then also manageability. So these are some of the features of the server. Now, for manageability here, it means that a server must be manageable. That is, you can be able to do an online diagnosis of the server, okay? And you can also be able to repair the server while it's working, okay? So these are some of the features of the server, okay? Servers versus PCs. So here we have an indicator, the servers, PCs. Here we have processor performance, okay? Here we have mount processor supported high performance. So in terms of availability, the server, you know, it must be available. You can see it's high. And then for PCs, relatively low, okay? So let me take you back to processor performance. With servers, these must have mount processor supported higher performance. Well, for PCs also, they can have mount processors, but the support has to be for low performance, okay? In terms of availability, the server, you know, the availability is higher. Well, for the PC, it is low. Usability for the server, it is higher. For the PCs, it is relatively low. Okay, scalability for the servers, it is also higher. Well, for the PCs, it is relatively low. And then for manageability, for the servers, of course, it has to be high. And then for the PCs, it has to be low. Server classification. So we can classify these servers by application level. Okay, so we have what are known as entry-level servers, work group servers, departmental level servers. These, you know, they work at departmental level, and then enterprise level servers. We can also categorize servers by system architecture. Okay, do these servers run on 32-bit servers, or are they 64-bit servers? Okay, and then also by appearance. So we have the rack server, blade server, tower server, and cabinet server. Also, we can categorize them by usage. So this is where we have general purpose server, okay? So this is a server, maybe it has the email server and then the file server and the database server within the single server, okay? And then this is the functional server. Maybe this server, it is just a DNS server, or maybe it is just the HP server, okay? That's how it is. So this is server classification here, okay? So the rack server, this is the rack server, what you are seeing here. It is the best-selling servers. It has a small chassis and multiple servers can be installed in one cabinet, okay? So this is a server here, okay? So you can see they can be, be put together, okay? So I've got 1U here, 2U, and then 4U rack server. So this is the tower server here. The traditional server type, large chassis dimensions. It has strong internal scalability, and also it occupies, a larger area in an organization. So this is the blade server here, high density server, energy efficient, centralized management, and quick deployment, okay? And then these here, these are cabinet servers, okay? These are cabinet servers here, right? Common server software. So we have the file server, dealing with files, database server, deals with the database, then the mail server, deals with emails, web server, okay, web applications, and then file transfer protocol server, the DNS, and then we have the NTP server, okay? The NTP server, it makes sure that all the devices in your organization are running on the same time. All of them, they have the same time. This is very, very important. So when you are tracing an attack, it is very, very important that the devices are running on the same time. Because if these devices, they are running on different time, how are you going to correlate the event? It would be impossible. So to maintain the same time in the organization, it is very, very important. So this is the work of the network time protocol, okay? And then this is the proc server. So when you talk about the NTP server, they get time from other servers from the internet, okay? And of course, these servers, they are in levels, and these levels, we call them stratum. So we have got stratum 0. So these are the servers with the correct time. And then we have got stratum 1, 2, 3, and so on. The closer the NTP server is to stratum 0, the more accurate the time is going to be. And then these are the proc server. So we have an example of the file server here. This is the file server, okay? So this client, when it wants a file, it always, get from the file server. So the client will be asking, and then the server has to provide. And then this is, the topology, which is a network structure of a database server. Okay, the topology of a network, and then we have the database server here. okay? So, of course, database server, it is there for, to manage data, to make sure that there is security, okay? And then the mail server, it handles emails, okay? So we can have the servers here. This is the agent sending an email. This email server will receive it, and then it can send it to the other email server. Then this email server will send it to the receiver, okay? So this is the job of the mail server, to handle emails. And then the FTP server is a computer that provides file transfer and access services on the network. So the FTP transfers and manages files. It also provides user identity of different levels. So here we have got the user, the guest, anonymous. Okay, so these, they must have different access levels to the file, okay? And then the DNS server, it consists of the DNS resolver, the DNS server. We looked at this already. So the DNS server, it stores the domain names and IP addresses. I gave an example last time, saying there's no need for us to know the IP address of Google because we're not good at keeping the numbers in our brains. We are good at remembering the names. So when you want to go to Google, you just have to type Google. Okay, so that once you click enter, that information, it goes to the DNS server, where the DNS server has the names with respective IP addresses. So it is going to match. And then once it has matched, that's when now to go to the server. And of course, that's when, the Google is going to appear on your screen. Okay. Server security threats. Okay. So the server faces so many threats. One, we have malicious programs, malware. So these are viruses, Trojan horse, the worm, spyware, okay, here. And then brute force cracking by hackers, okay? So with brute force, here, the hackers, they have got tools which they use to try to guess the password. So this tool, it will be, trying a number of passwords which it has in its database, trying to guess the password, okay? That is brute force. And then we have SQL injection attacks, okay? With SQL injection attack, all right, on the web application. Now, on that web application, the web application can have the form where we have the name, where you can enter your name, your sign name, and so on. So where you're supposed to enter your name there, the hackers are going to enter malicious SQL statements, okay? So these statements, once the hacker enters them on the name, okay, that SQL statement, if your web application is vulnerable, the SQL statement is going to make your web application to give out the information which it has in the database, okay? Of course, this happens if the web application is not designed properly. That is, the designer did not put what we call input data validation, okay? So what is input data validation, all right? So when coming up with the web application, you can say in the program there that on name, I'm going to allow only letters, okay? So if you don't do that, then the hackers, they can enter a SQL script having so many characters, numbers, and so on and so forth, okay? So input data validation is very, very important, okay? So we have so many malicious SQL statements. And then, of course, DDoS attacks. So the server also suffers from a DDoS attack. Okay, so this is one of the common attacks there that can be done at any time. You just have to go to the dark web and you can be able to buy a botnet, which you can use to attack a Sten server. And then system vulnerabilities. These are the weaknesses of the server system. Maybe it is not updated, or maybe there's a patch which was released and you didn't patch, okay? So these vulnerabilities lead to all these problems which we have, okay? All right, so malicious programs have explained about these, okay? So malicious programs are usually written with attack intention, and we can divide them into two categories. The first one is threats dependent on host programs that cannot take effect without an application. And then we have also independent threats in a self-contained program that can be scheduled and run by an operating system. So these are examples of malicious programs, or what we call malware. So you have the Trojan horse here, the worm here, and the viruses. So it is very, very important that you differentiate these. Okay, we are going to look at how to differentiate them in this same lecture. Okay, brute force cracking by hackers. So here we have the hacker, okay? Here is the server, okay? And the server, and the hacker wants to have access to this server. He doesn't know the password. So he has a tool, and this tool has well-known passwords and other things in the database, okay? So this tool will keep on trying the password. So it will try this one, it has failed. And then, it does this process very, very fast. And then it's going to try this one, failed. And then lastly, it is going to guess the correct password. Why does this happen? It is because you configured a weaker password on the server. There's no way you can configure such a password, Huawei at 123. And I've seen that here, most of the people have continued, with, creating such weaker passwords. I've been saying that you must have a strong password. A strong password is one with uppercase letters, lowercase letters, a number, a special character, and you don't have to use those words in the dictionary, okay? And of course, it must have at least 8 characters and more, okay? Now, again, here comes in another problem, because some people say that a strong password is the weakest. That's what they say. Why they, say that, it is because if you have got a longer password, then you'll be forced to write it down, right? But you can make a stronger password by using what is known as a passphrase. Okay, a passphrase is something like, you know, Andrea Teo lives, so you get the first letters, lives in Charleston, house number, so. That is what we call a passphrase. So you can get the first letters. So when you have got a passphrase, then it will be easier for you to remember a longer password. Okay. SQL Injection Attacks. So this is the website here, poorly designed. Okay. So the hacker is going to enter my SQL statements here, and these statements, they're going to manipulate the database to give out information to the hacker. This is the DDoS attack. Again, we have the hacker here. You know, he's called the bootmaster if he's managing the bootnet. And these are zombies, the infected computers on the internet. Okay, so they are going to be programmed in such a way as to send traffic, to flood traffic to this server here. The server will be bombarded with so many requests that it won't be able to reply to legitimate requests. Okay, that's how it is. Okay, so common security threats defense methods. All right, so how do we protect our organization from malicious programs? One, do not install suspicious software. So this is very, very important. This is why the organization must have a security policy, because a security policy is going to state which software is going to be allowed in the institution. There is no way that in this organization, everyone is just installing any type of software. It doesn't work that way, because anyone can install now a Trojan horse. You know, if you like free programs, okay, you're going to install a Trojan horse. Okay, do not open a link from a known sender. So this is very, very important, not to open a link from a known sender. Okay, so this is now phishing. So this link can be malicious. You have to install antivirus software, and of course, it has to be up to date. Now here, you don't have to install free antivirus software on your organization. Okay, today on my Facebook page there, I have posted the best antivirus. And of course, there's a company called AV-Test in Germany. This is an independent security company. So they do analyze, antivirus. They check them on how capable they are in detecting viruses, you know, the usability of these antivirus, and so on and so forth. Very, very important. Do not access suspicious websites, okay? So here we have, tools like the DLP, data loss prevention. You know, this is one of the tools which can prevent employees from going to dangerous websites. Brute force cracking by hackers. How do we protect our servers from this attack? We have to set up a complex password, and then we change the default port numbers, okay? We have to disable password login and only allow login using an authenticated secret key. Okay, SQL injection attack. How do we protect our servers? We have to use regular expressions to filter input parameters. I talked about input validation. You have to use pre-stated statements instead of statements. And then you have to, you invoke this function in Java server pages to check for invalid characters. DDoS, how do we protect our servers from DDoS? We have to use what is known as source authentication. Okay, so to authenticate the source, that is where the data is coming from, fingerprint learning, and then also domain name redirection. Okay, vulnerabilities and patches. So a vulnerability is a defect or a weakness in the hardware, software, or protocols or computer systems, or in security policies. So that is the definition of a vulnerability. So vulnerability hazards. So if you have got the vulnerability, what can be the consequence? We have permission bypass, permission escalation. That is, what hackers do. First of all, they are going to hack the system, and the permissions that they're going to have are the permissions of a standard user. Okay, so they can go further and get the rights of an admin. That is what we call permission escalation. You're going to suffer from DDoS attack, data leakage, and then execution of unauthorized instructions. So vulnerabilities can lead to all these problems. Vulnerability classification. So we can classify them by exploitation method. So the exploitation can be locally or remote, coming from very far. Okay, so here, the local exploitation, it is for, the insider threats, okay? Or by location, where is this vulnerability? Is it in the operating system? Is it in the protocol stack? Is it in the non-server program? Is it in the server program? Is it hardware? Is it through communication protocol, password recovery, or other types? Okay. All right. And then also we have levels of vulnerabilities, where we have high level vulnerabilities. Of course, this is a vulnerability which can give the hackers to have the permissions of an administrator. And then medium level vulnerabilities, this is for the standard user. And then we have low level vulnerabilities. So what are some of the causes of system vulnerabilities? Defects in software or protocol design. And these defects, it comes from the errors of the coders, okay? Some bugs in software compilation, improper system configuration. So here, maybe you have left the devices having, default settings. Of course, you saw yesterday the default username of a Huawei firewall and the default password, okay? And then limited security awareness. Security awareness is very, very important in the organization, okay? Vulnerability scanning. So this is very, very important. Vulnerability scanning here, the attackers are looking for vulnerabilities. First of all, they are going to start by, allocating the hosts or the network through the use of the pings, okay? And then they collect further information about the target. That is, what type of an operating system is running on this device, okay, and services, all right? So we have, these are common scanning methods. There's port scanning, which can be divided into 3 types, okay? So we have full scanning. Full scanning, this is when, yesterday I talked about you being an ethical hacker or a pen tester, okay? Very, very important that you can be able to do this to your organization. So you can be able to do what we call a full scan. So with a full scan, this is where now you are going to send a SYN message, and then you're going to receive a SYNAC, all right? And then lastly, an acknowledgement, okay? So if you have that, then that is going to show that the port is open or the port is working, okay? And this is how the attackers, they do it. And then we have the SYN scanning. So with the SYN scanning, here, the attackers, they send the SYN packet, okay? And if they do receive the reset packet, that shows that the port is closed, okay? But if they don't receive anything, that indicates that the port is open, it's working, okay? And then there's the stealth scanning. So with the stealth scanning, here, the attackers, they send the FIN packet, okay? If they do receive a reset, it means that that port is closed. But if they don't receive anything, it means that that port is open. Then we have system vulnerability scanning, which can be divided into 2 parts, passive scanning and active scanning, okay? So with passive scanning, this is where you can go physically and, you check, is the password strong or weak, okay? What type of services, what type of vulnerabilities are here, and so on. And then active scanning, this is the actual pen testing, where, you can hack your system to try to find out the vulnerability, okay? The definition of a patch. All right, so once we have these patches, we are supposed to mend them. Once we have the vulnerabilities, we are supposed to mend them with the patch, okay? So here, the programmer made a mistake. There is a vulnerability, okay? The programmer is going to develop a patch which you can use to mend the vulnerability. That's why you have seen time and again, we have to update Windows, because Windows has to release some patches which are needed to be mending the vulnerabilities. Typical vulnerability attack cases. So of course, we talked about this, the WannaCry ransomware attack. So, it happened in 2017, and you can see this is the vulnerability that was exploited by the hackers. So the hackers, once there is a vulnerability, they create a tool which is called an exploit to exploit the vulnerability. So this is the vulnerability which Windows had, okay? So a number of files on computers were encrypted, and of course, that is, they were locked, and hackers, they were demanding a ransom of $300 US. Of course, it has to be in Bitcoin so that you can't track the hackers. So this is how it looks like, you know. So here you have the time. The time has to be ticking. It is either they're going to say that we're going to delete the data or we are going to disclose this information. So you'll be in a panic mode, panicking. And you can see this is, you have to pay in Bitcoin. And here, this is where you enter the key. That is, after paying, you'll be given the key, which you enter here. And this key will be able to decrypt your information. Okay. And then this is another case for the Drown vulnerability. So in 2016, a new security vulnerability Drown was found in the open source encryption tool, OpenSSL. Okay. So the vulnerability allowed hackers to attack websites and read encrypted information such as passwords, credit card accounts, business secrets, and financial data. So this was a huge security challenge for global websites. So you can see that in China, about 100,000 websites were affected. So this is the Drown vulnerability. So how do we defend ourselves against these vulnerabilities? The first one is system update, and this has to be done promptly, okay? And then you have to disable the services that you are not using. You disable the ports, okay? And then you have to improve security awareness. You know, security is for everyone in the organization. And then, of course, you have to scan and kill viruses, Trojan horses in a timely manner. Okay. So time for a quiz. Which of the following is a server that provides file transfer and access services on the network? So as I've been saying, make sure, be careful when reading the question. Make sure that you understand the question to the fullest. File transfer protocol, DNS, NTP, database. Of course, here it is FTP. FTP deals with files. DNS deals with matching names to IP addresses. NTP is for time. Okay. Database server, it deals with the database management, and so on. You know, so this is how you do it. You can sometimes use elimination method because some answers, they don't make sense at all. Okay. Which of the following are the causes of network vulnerabilities? Defects in software or protocol design? Yes. Bugs in software compilation? Yes. Improper system and network configuration? Yes. Okay. Unlimited security awareness? Okay. Can this cause a vulnerability? You know, what is a vulnerability? A vulnerability is a defect. Okay. So it has got to do with improper system and network configuration, bugs, as well as what? As well as defects. Right. So we will continue. At the end, that's when I'll go back to lecture 1 so that you ask some questions. Okay. Host firewalls and antivirus software. Firewalls were first applied to buildings to isolate fire and prevent fire from spreading from one area to another. In the communications field, firewalls are mainly used to protect a network against attacks and intrusions from other networks. Antivirus software is a type of program tool that is used to remove known harmful program code, such as viruses, Trojan horses from computers. Objectives. Upon completion of this course, you'll be able to describe the definition and categories of firewalls, describe the main functions of firewalls, describe the concept of antivirus software, distinguish antivirus software from firewalls. Contents, we are going to look at firewall overview, okay? So what is a firewall? So this is your organization. A firewall must be here. This is the internet. And from the internet, this is where we have bad guys, okay? So a firewall is a method of separating a private network from a public network. So the internet is called the public network, okay? It is actually an isolation technology. A firewall allows only authorized people and data to access a network and prevents access from hackers. If data fails to pass through a firewall, people on an internet cannot access the internet, and people on the internet cannot communicate with people on the intranet. So this is how it is. We have got the firewall here. We are protecting our organization. So we can put the rules on the firewall and say that any traffic which is coming from the internet, trying to enter our organization, it will be blocked. But traffic which went to the internet and is coming back, it has to be allowed. Firewall classification. So they can be classified one by form, okay? By form. So here we have got two types. Hardware firewall. So this is a device, you know, on its own, it is a firewall. And then we have got software firewall. This is software like the one that you have on your laptop. So Windows comes with a firewall. That is what we call a software firewall, the one which is inside your laptop. By protected objects, these are standalone firewalls or network firewalls. Okay. Windows firewall. So, you know, Windows has got the firewall which comes with it. Okay. And the purpose of this firewall is to filter the traffic which is going inside your laptop. So this is how it is. Okay. So you can go to the command prompt, then you go to system and security, and then finally you're going to find Windows firewall. Okay. So these are some of the features where you can allow an app, you can change notification settings, you can switch on or off the firewall. There is the restore defaults as well as, you know, advanced settings. Okay, so this is the part where you can allow the applications to connect to the internet or not. And this is the part where you can switch on or switch off the firewall. Okay, and again, you can restore the settings of the firewall to the factory settings, okay, by clicking the restore default. So this happens when you have issues. Maybe you can't connect to the internet. Okay, you can do that. Okay, and then it also has the, you know, advanced features where we have got inbound rules, outbound rules. So this is where you can set up your own rules, okay? You can set up your own rules. So how you set up the inbound rules? You just have to click inbound rules and then new. Then here you can pick whether you want to, to come up with a rule which deals with the program, the ports, and so on. Okay. Linux firewalls. Okay, just a minute. Right, so Linux also, it comes with its own firewall, which has evolved over, time. So these are the, the versions with, firewalls, where the first one was the IP firewall, IPFW ADM, IP chains, and IP tables. So this is the IP tables structure, where you have the IP tables followed by the table, the chain, and then the rule. So we have the rules. So rules are the ones which are going to either allow traffic or block it. So this is a table. It is followed by the chain. Inside the chain, we have the rules. So we use the rules either to allow traffic or to block it. So this is the basic concepts of how the IP table works. And, we have the rule here. So this is the rule, which says source address, this one, destination, we are going anywhere. The protocol which is involved is HTTP, action, permit. Now, if you check here we have got .2, but here I've got .1. Therefore, this PC, when it wants to go to the internet, it won't. It will be blocked by the firewall because of this rule that it has. Okay. Right. So you can see that the chain can have so many rules. It depends on what you want to allow and what you want to deny. Okay. The table, it provides specific functions. So the IP tables, it contains 4 tables. It has the filter table. The filter table permits or denies data packets. And then it has the NAT table. This one translates addresses. We're going to look at NAT later on. And then the Mango table, which modifies packet data. And then we have also the raw table, which determines whether data packets are processed using the state tracking mechanism. Okay, so this is the process of transmitting data packets by IP tables. So we have the inbound data packets here. Okay, we have got the inbound data packets here. And, the firewall has to check to see the destination IP address, okay? So if the destination, is not going to the very firewall, it has to be forwarded, okay? But when it is going inside, then, it has to be sent to the input chain. So these are the, the IP tables rules. This is the structure, okay? So the structure starts with the IP table, where here we have got, -T table, followed by command, chain, criteria, -jump, and then the action. So the -T table specifies the table to which the rules apply. Remember, we looked at four different types of tables, which are filter, nat, mango, or raw. And then the command defines how to manage rules. Then we have the chain, which specifies a chain, and then the criteria, which specifies matching criteria. We have the -J action. This one, it is for the action to be taken. So we have an example here, which says access to this network is not allowed. Okay. How do you create the IP table rule for this? This is how you do it. IP tables, -T, which table? Filter, -A, input. Remember, we looked at input, output, and then this is the source. So this is the source where traffic is coming from. And then -P, it is for protocol. Which protocol are we dealing with? We're dealing with UDP. And then --, this is destination port. UDP is what? Port 53. And then jump J, it has to be dropped. So anything which is coming from this network, it will be dropped according to this rule that we have put in the IP table. Okay. Antivirus software. So antivirus software is a type of software used to remove computer viruses, malicious software, Trojan horses, and other computer threats. Its functions include monitoring, identification, virus scanning, virus clearing, automatic upgrade, and proactive defense. Okay, so these are the functions of antivirus software. Virus prevention, it protects your computer from viruses. Virus identification, where it has to scan for viruses in programs or files that are running on your computer. Then virus clearing, where it has to restore the infected files. You know, that's how it is. So these are the components of antivirus. It has the scanner, you know, virus signature database, and the virtual machine. So this is how it is. It has the virus database, scanners. Others, they have the VMs. Okay. So what are some of the key technologies of antivirus software? The first one is unpacking. That is, if the file is zipped, the antivirus will unpack it and check what it has. Okay. And then self-protection. So the antivirus itself, it has to protect, you know, itself from viruses. And then also the other technology is repair. Okay. You find that when the virus is clearing, I mean, when the antivirus, sorry, is clearing the file, you find that it can delete some of the files. So the antivirus has the capacity of repairing the files. And then also real-time update. So the thing here, we know it, that each day, thousands and thousands of viruses are being developed. Okay. So with the manufacturers of virus, what they do is, once there's a new virus, they will study that virus and then they'll come up with its signature. This is the reason you are updating your antivirus, you are updating its database with new signatures, which are for new viruses. So the virus has this feature, real-time, the antivirus has this feature, time, you know, update, very, very important. And then proactive defense. is very, very important. That is, sometimes when you have a flash, an infected flash, when you plug into your system, you find that automatically the virus is going, the antivirus is going to detect it. That is proactive defense, protecting your computer from being infected. So these are the mainstream antivirus software that are in China: Kaspersky, Rising, 360, and so on. Okay, so what antivirus software do users need? They need something which is antivirus effective for real. Is it working or it's not? So this is why I talked about the AV test, an independent company in Germany which analyzes the effectiveness of antivirus, because some antivirus are not able to detect virus. And then occupied resources, that is when the antivirus is working, what resources is it? That is what amount of resources is it using? That is in terms of the CPU and RAM. Okay, because I remember when I was a student, we had an antivirus, I think it was Dr. Web. So when I ran it on my laptop, and then even the speed of my laptop would become slow. So that already showed that Dr. Web was consuming much of the CPU power and RAM. And then antivirus speed, that is how speed is this antivirus in detecting viruses. And then of course, lastly, the user interface. How easy is it to use this antivirus? It is very, very important, because there's no way whereby users will be struggling of how to use the antivirus. Okay. That's how it is. Now, common knowledge of antivirus software is that antivirus software cannot scan or kill all viruses. Okay. Antivirus software cannot kill all scanned viruses. That's why there's need not to depend only on one technology. When you are protecting your organization, you have to use different techniques. That is, you have antiviruses. You also must have the host intrusion prevention systems, the host detection systems, okay, content filtering appliances, and so on. When protecting an organization, you have to use different technologies. Again, it is also unnecessary having 2 or more antivirus software in your system. With me here, I'm comfortable with Windows Defender. It comes from Microsoft and it comes with the operating system. I'm comfortable with it, no problem. And of course, the AV, the rated Windows Defender are very, very high. Okay, so we must have one antivirus system, and it has to be updating. So antivirus software may clear, delete, forbid access to, or isolate files. Okay, all right. The quiz: which of the following categories does Windows Firewall belong? If you remember, I said 1, it has to be software firewall. Okay, software firewall comes with Windows and it comes with the operating system. Okay, so it's software firewall. And then of course, standalone, because it's only protecting this very laptop. Okay, so here 2 answers. Okay, so which of the following are components of antivirus software? Scanner, yes. Virus signature database, yes. VM, yes. Have you seen here? Firewall, this does not make sense at all. Okay, so a firewall can't be a part of the antivirus, but the antivirus can be a part of a firewall. That is, apart from having a firewall, remember we looked at the UTM devices. Okay, so the firewalls of nowadays, we call them, new generation firewalls. So we find that it's the firewall, but it also has the antivirus within it. It also has the intrusion prevention system. Okay, so this was the last topic in module 2. Move on to module 3. We'll start module 3. So this is our module 3 here, Introduction to Firewalls. So now we are looking at firewalls a little bit in detail, okay? And this is just the first level of CCNA. There is another level, which is the professional level, where again, you learn a lot about firewall. Very, very interesting indeed. Introduction to firewalls. So during data communication, insecure factors may cause information leakage, incomplete information, unavailable information, etc. Therefore, firewalls are required during network deployment. This course introduces the history, features, typical networking modes, application scenarios, and technical specifications, of Huawei firewalls. Objectives: upon completion of this course, you'll be able to understand the basic concepts of firewalls, understand firewall security policies, have a good command of firewall security policy configuration. So we are going to look at firewall overview. All right, again here we are. This is the internet here. We have the router. Remember the router? We looked at network devices yesterday. The firewall is here, and then this is our organization. So these are some of the features of firewall. Logical area filter, hiding the intranet structure, what we have, security assurance, and proactive defense. That is, before the attacks reaches our organization, they have been blocked by the firewall. Firewall classification. The first type is packet filtering firewalls. Remember, we looked at this yesterday. This was the first generation of firewalls. And, they would set up the rules using what we call access control list. That is filtering the traffic according to the destination address, the source address, destination destination port number, source port number, the protocol type. So it was filtering the traffic based on those parameters, okay? Then came, and of course with packet filtering, it was filtering one packet after the other, one packet after the other. So in terms of efficiency, it wasn't all that, and it was slow because of that, okay? Then came the proxy firewalls, okay? So a proxy, it is a device whereby if your laptop wants to go to the internet, it will go to the proxy. And then the proxy is the one which is going to go to the internet, okay? So the proxies, at least, they are good, but they have some disadvantages in terms of the speed. It is very, very slow. And for each application, you have to develop its own proxy, and of course, in terms of updating, that is coming up with a patch and patching, it takes long, okay? Then came this one, stateful inspection firewalls. Okay, so advances were made. With stateful inspection firewalls, how it works is like this. When it receives a packet, it will take note of that packet and put the information in the session table. It follows what we call the data flows. So in a data flow, we have the first packet. Once the first packet has been examined, these other packets, subsequent packets, are going to be allowed to pass. That's how it works. So with stateful inspection, you find that the efficiency of firewalls was, very, very good, and they were very, very fast. Okay, and in taking into consideration the status, the connections, and so on, this improved the security of the firewall, because when data went and when coming back, it has to be checked whether that information is there in the session table or not. Okay, so with packet filtering, attackers were able to bypass it because they would learn which IP addresses were being allowed to pass. So they would falsify the IP addresses and data would pass through packet filtering firewalls. But with stateful, when they are coming, the firewall has to check whether its information is there in the firewall or not. This is the goodness of stateful, because they track the communication. And when the transaction is done, that information in the session table, it will be removed. Okay, so stateful inspection firewalls, they are very, very effective, and they are being used up to now. Okay, so this is packet filtering firewalls. I've explained about this. Okay, so we have the PC here. This is the firewall. So when we set up the rules, we are going to filter based on the IP address. What do we have in the IP layer? What we have in the IP is the source IP and destination IP. And then what do we have here in the TCP layer? What we have here are the source and destination port numbers. So it is going to filter, that is, it's going to filter traffic based on this information. Okay. So packet filtering is unable to associate data packets, is unable to adapt to mount channel protocols. Remember, we looked at FTP, which uses 2 protocols. Okay, so when connecting, it uses port 21. Okay, and then when we have the actual data communication, it uses another port. So when this traffic is coming back with a different port, of course it is going to be blocked. So these are some of the disadvantages of packet filtering firewall. Okay, not check the application layer data generally. Okay, so this is the proxy firewall, which is the second generation. So when the PC wants to get something from the server, it has to go through this proxy firewall. Okay, so it is slow in terms of processing because it is software based, and then difficulty in terms of upgrading. I've talked about that earlier on. And then this is stateful inspection, third generation of firewalls, where we have the first packet. That first packet, the firewall will take note of its status okay? And then the other packets in this flow will be allowed to pass through, all right? And because of that, stateful inspection is very, very fast. High security is in that after the communication, that information which was in the session table will be removed. Okay. Firewall networking mode, so they can work in two modes. In the first mode, this is where we have firewalls, you know, working at layer 2. That is, they're not dealing with any packets. Okay. And then the other one is where now firewalls are working in layer 3, where they're dealing with packets. And of course, here we can make the firewall to also be able to accommodate other devices such as the antivirus, as well as intrusion prevention. So the principles of firewall forwarding, packet filtering technologies. So when receiving a packet, the firewall gets the header, compares the header with specified rules, and decides to forward or discard the packet. So the core technique for packet filtering is what we call access control list. An access control list, it is a list of statements that these are permit and deny statements. Okay, that is how you know, packet filtering technology works. Okay, firewall security policies. Security policies control traffic forwarding according to specified rules and apply integrated content security detection to traffic. Okay, the rules focus on packet filtering. Okay, major applications. Security policies control network communication through the firewall. Security policies control access to the firewall itself. So the rules, these are the security policies that we put in place. So even to the firewall, we can do it in such a way that we can configure an access list saying that only this IP address is going to be allowed to manage the firewall. Okay. So this is the policy mechanisms. These are the policies. Have you seen here? There's policy 0. Permit subsequent operations of A. Policy 1. Deny subsequent operations of B. Have you seen? This is traffic coming with A and B's, but after the firewall, only A will be allowed. So this is how it is. And then, of course, at the end, we have the default policy operation, which is always deny. Okay, which is always deny. Okay. Firewall interzone forwarding. So this is where we have the trust zone here and untrust zone here. Okay, and then here we have the policies. So you can see permit from this network, deny from this network. Okay, and then the default, which is deny. So we have got two zones here. Because these are two different zones, then we can restrict traffic by coming up with the policies. Okay. Querying and creating sessions. So we have query the session table. Is the session table matched? Yes. And then you have to perform the security check and so on. If no, and then you have to check for these other conditions. Okay. Static inspection mechanisms. So here I talked about this. So when this static inspection is enabled, a session can be created only when the first packet passes the inspection performed by the firewall. Subsequent packets are forwarded based on the session which has been created. Okay. When the static inspection mechanism is disabled, even if the first packet does not pass through the firewall, subsequent packets can trigger the generation of a session as long as they pass through the firewall. Okay, so with next, with new generation firewalls, so this is the information that we have in the session table: source address, source port, destination IP address, destination port, the protocol. It has included the user, monitoring the users in the organization, as well as the applications. Okay, so next generation firewalls are able to distinguish the users in the organization. They are also able to distinguish different applications. So you see, if they say, we don't want our students to be accessing Facebook, they'll just come to this firewall here and configure that policy. And for sure, no one from here is going to access Facebook because the application will be blocked by the firewall. Querying the session table, describe brief information about the firewall session table. So this command, have you seen, where is it done? Which mode is this? We talked about this yesterday. When you see these brackets, it means you are in the user mode. So this command display firewall session table. It is going to tell you about the total sessions that are there, the protocols that are involved, okay, and the direction. Okay. Now, if you want to know more about the session, at the end of this command, you add the word verbose, and then you are going to have a lot of information, about the firewall session table. Move on to firewall security policies and application. Okay. All right. So we said that the firewall must have the policies which are going to allow or permit traffic. So this is the matching process, where first of all we have the condition. So when traffic is coming, it is going to to suit these conditions, and then it will be followed by action, whether that traffic is going to be allowed or denied. Once that traffic is allowed, and then if it is referenced to a profile, let's say antivirus, it is going to pass through the antivirus. If it is intrusion prevention, then it's going to pass through intrusion prevention, and so on. So this is how it works. Okay. So I talked about the application of policies, where in an institution, the firewall can be able to know that this traffic is coming from this department. So we can have this security policy here, which says source address, any PC, destination address going to any destination coming from the marketing department, applications, instant messaging, chatting, gaming, action what? Deny. It means the people in the marketing department won't be playing video games at work, they'll be denied. Or we can configure another policy where we say source any, destination any, coming from this department, the protocol which is involved, HTTP, we are going to allow. So these are going to be allowed to go to the internet. That's how it works. Okay. So configuring the firewall security zones using the web interface. Okay, so I even said yesterday that by default, Huawei firewalls have got 4 security zones. So how do you configure a security zone? You come to network zone, you add, okay? And then you can choose. So we have got the local zone. The local zone, it is the firewall itself, the trust zone, and trust zone, and the DMZ. So you pick whichever you want. How do you configure the policies using the web interface? Okay, so the policy must include, we have just seen, matching conditions, these, action, and then content what? Security. So we have an example of a default policy which has been made here. So this is the default policy which is there. Okay, so the source is any, destination any, and then action what? Deny. So this traffic, it has passed through all the policies, nothing, and then finally it has to be denied. That's how it works. How do you configure the addresses? You have to come to object, address, and then you add them, okay? You can also be able to configure these Huawei firewalls by regions. So again, it's object, region, and then you choose. You say, I don't want any traffic from, the UK and so on. You can be able to do that. How do you configure the services? And then it's object, service, and then you add the services. The same applies to the application. And then you can also set the time. That is, you can say, after 18 hours, no one will be allowed to access the company resources. You can do that. You come to object, schedule, and then add. And then say from 8 up to 18, these people, they're going to be able to access company resources. But immediately after 18, you won't. Okay. Configuring a security policy, you have to give it a name. You can even also describe it, and then you put in the parameter. So this is an example here. We have this enterprise network with PCs coming from this network segment. These will be allowed. And then these PCs here are not allowed access to the internet. So this is your organization. You have been given this task to say you are going to allow this, the PCs coming from this network, but these ones, please don't allow them to the internet. How do you do it? So these are the steps. You start by configuring the zones, and you can see that these in blue, they are mandatory. And then you can create the zones, you configure the interfaces, and then you configure user and authentication. This is a topic we're going to look at later, next week. And then this is configure the objects. So this is what you do. You create the profiles. Then you configure a security policy, you save and commit. So this is how it's done using command language, and you must know this. And I said yesterday that it is easy to use the commands because the operating system is going to help you with the help command, which is the question mark. So how do you configure a security policy? You start with the command security policy, and then you give it a name with the command rule name. You put any name. And then source zone, it is a trust zone. Destination and trust. and then source address, you put these PCs, and then action, deny. And then this is for the other one, root name, of course, the names have to be different. And then source zone, trust, destination zone, and trust. Source address, this network, action, permit. Okay, so this is how you do it, using commands. How about using the web interface? It is easy. You just write the name there, and then these are the networks, okay? And then the policy, you give it the name, the directions, action, deny. How about for the other one, you give it a name, permit, the direction, trust, and trust. This is the network, and then action here, permit. As simple as that, how to configure a Huawei firewall using the graphical user interface. Okay, the last content is ASPF. So what is ASPF? Remember, we looked at mount channel protocols. How does the firewall deals with this? So a mount channel protocol is one with 2 or more ports, like FTP, okay? So here, the ASPF is an advanced filtering technology which checks application layer protocol information and monitors the status of connected application layer protocols. So it creates what is known as a server map to allow these protocols having more than one port number. Okay, so this is how it is, because if we're using FTP and then we go to the internet, and coming from the internet, this traffic is coming with a different port number, it will be dropped. Okay, so the purpose of ASPF is to make sure that mount channel protocols are allowed to, to go to the internet and come back by creating what is known as a server map to map the ports. So what are some of the situations where this server map can be generated? Okay, server map entries are generated when we use mount channel protocols such as FTP and RTSP, okay? And when we involve simple transfers of UDP through NAT protocols, okay? And also in a situation when NAT server map is configured, and lastly, in a situation when we have NAT NOPAT is configured, okay? The other support for mount channel protocol is port identification, okay? Port identification, which can be configured using an ACL. So this is how you configure an access control lists. So you say access control lists, okay? So this is 2000, and we have different access control lists. There's the basic access control lists where you can pick the numbers from 2000 up to 2999. And then we have advanced access control lists. This is where you can pick a number from 3000 up to 3999. And then also we have, the MAC ACLs, where the MAC addresses are being used. This one, you can pick any number from 4000 up to 4999. So you can see here, this is a basic SL because of this 2000 here. So rule, permit, source, this, and then you map it with the command port mapping, FTP, this port, and then you map it to the SCL. So port identification is also used to support mount channel protocol so that I can be able to pass through the firewall without being dropped. Okay. The fragment cache, what is this? So you find that sometimes some devices cannot allow a certain size of a packet. Okay. So that packet has to be divided into smaller chunks. Now, when that information is going through the internet, you find that the first chunk can't be the first one to reach the firewall. So when these other chunks first reach the firewall is going to drop them. Okay. So with the fragment cache, what it does is, you know, the firewalls, first of all, I mean, the packets, the chunks, you know, they have to be stored somewhere and then reassembled so that they'll be allowed to pass through the firewall. Okay. Persistent connection. So we have what is known as edging, whereby the edging of the firewall table can lead to the drop of the packets. Therefore, it is very, very important to configure constant connections so that the packets are not dropped. Okay. So the quiz, you can see here, which of the following situations will server map entry be generated? NAT no part is configured, yes. NAT server mapping is configured, yes. ASPF is configured, yes. So these three. True or false, very tricky questions as well. Therefore, you have to be very, very careful. Now, how do you become successful in answering these? You know, here you have to read and understand each and every sentence in the material. So a firewall has 4 default security zones, true, and the security levels of the zones cannot be changed, true. Okay. So now we'll look at the last lecture for today. The last lecture for today, which is NAT. Network address translation. Forward. So NAT translates an IP address colored in the header of an IP packet into another IP address. Generally, NAT is used to translate private addresses into public addresses so that devices can communicate across private and public networks. Okay, to alleviate the public address shortage caused by network expansion, NAT emerged as a temporary solution. So here, the way it is like this. When the internet was being made, we were using only IPv4. And IPv4 is a 32-bit address. So that gives us about 4 billion IP addresses. Okay? So when they were coming up with the internet, they never thought that the internet would be growing. So the internet started growing and we were running out of IP addresses. Okay? So what can we do to increase the number of IP addresses? Somebody came up with NAT. So here we have what are known as private addresses and public addresses. Okay. So private addresses are the IP addresses that can be used by so many organizations. So many organizations. For example, UNZA can have the same addresses as Evelyn Horn, as Murungushi University, and so on. But these computers with private addresses, for them to connect to the internet, they need to use a public address, okay? So these addresses, they have to be NATed, okay? That's the idea. So objectives, upon completion of this course, you'll be able to recognize NAT application scenarios, understand how NAT works, configure NAT on firewalls. The contents will start with NAT principles. So the background, of course, we were running out of IPv4, okay? But, you know, later on, you know, somebody came up with IPv6. So an IPv6 has 128 bits. That gives us trillions and trillions of addresses. So IPv6 could not immediately replace IPv4, okay? So to overcome this problem, NAT was introduced, okay? So what are some of the advantages of NAT? IP addresses can be reused by so many organizations. That is the same addresses. But you cannot use the public addresses to connect to the internet. For you to connect to the internet, you have to be NATed. That is, you're supposed to use a public IP address. The address transaction process is transparent to users. That is, users are not aware that there's NAT. Privacy protection is available to internal users. That is, you know, internal IP addresses are not known to the internet. And then load balancing among internal servers is available. Load balancing, this is a situation where if you have got a number of servers, the traffic being received is divided amongst the servers. What are some of the disadvantages of NAT? One is that network monitoring is more difficult. For example, if a hacker has hacked your institution and he has used a public address, it becomes difficult to track him because when he goes to the internet, he uses another IP address. And then some applications are restricted. That is, traffic which is encrypted cannot be NATed. So this is the basic principle of NAT. So here, the public addresses, we have what is known as, you know, the classes of addresses, where we have got class A. So in class A, the IP addresses from 10.0.0 up to 10.255.255.255, that is, those are public addresses. And when you come to class B, the IP addresses from 192.168.0.0 up to 192.168, those are public addresses, okay? And then that is class C, sorry. And then class B from 172.16 up to 172.131. That is class B. Those are ranges of public addresses. So public addresses can be used by so many organizations. Okay. So here we are. Here we are. This is a public address, .10, as I said. So when it wants to go to the internet, it has to use a public address, another address. That's how it happens. NAT categories, we have got two categories of NAT. There is source NAT, which is further subdivided into what we call an address pool mode, okay? An address pool mode, source NAT. This is where, in terms of the public addresses, we're going to have a pool of addresses such that if someone with a public address wants to go to the internet, he will come to this pool, pick an address, and he goes. And then we have the outbound interface address mode, which is also called easy IP. Okay, so with this one, we are going to use the physical interface, let's say, of the router outbound, which goes to the internet, as the IP address we're going to use. So a PC with a public address, when it wants to go to the internet, it will use the IP address of this outbound interface. Okay, and then we have server mapping, which is also, it's called static NAT or NAT server. What is this? This is when we have the server in our organization and we want someone from the internet to access our internal server. So this is the only situation where we can configure static NAT. So we'll start with source NAT. Here's an example here. Okay, so this is our internal network. Remember, 192.168, this is a public address. Okay, this is the destination. So this address is going to be NATed to this one when it's going to the internet. So this is what we call NAT, because the public address cannot connect to the internet. So we're going to configure NAT here. Okay. So we have one-to-one address translation, whereby these are public addresses, these are private addresses, where when the PC comes, he picks the public address and then, he goes to the internet. So this is what we call address port mode without port translation. And then we have address port mode with port translation. So with this one, you can see we can have a single public address, but what is going to differentiate the connection is different port numbers. Okay. Easy IP, which is known as outbound interface. So here we are going to get the IP address of this interface, which is going to the internet outbound. So here it is. And then we are going to use the port numbers to differentiate these different connections. Okay. Now, NAT ALG, remember again, here we have got the issue of dynamic protocols, those with, multiple channels. So this is when, how do we deal with them? This is when NAT ALG comes in. So NAT ALG deals with protocols having more than one port numbers, okay? So we will have to configure NAT ALG to deal with FTP. Okay, NAT server. So here, this is our organization, and we want this gentleman from the internet to connect to our server. So we have to configure NAT server for this, gentleman. Okay. NAT server and server map table. So after NAT server is configured, the device automatically generates the server map entry that maps public and what? Private addresses. So this is the command we use to configure NAT server. So it starts as NAT server, here any name, the protocol involved TCP, global, this is from the internet, and then inside, this is our private address. This is the public address. So the person from the internet will be able to connect to our server. Okay, so we have some application scenarios here of how to configure source NAT and NAT server. So how do you configure source NAT? Using the graphical user interface. So you can give it the name and then the range of addresses that you want to be in the pool. Okay, and then you configure the source NAT policy. You give it a name. You have to choose which one you're going to use here. And then the directions. How do you configure the internal web and FTP servers? You have to give it the name, the IP addresses, you choose the protocol and the port numbers. How about the interzone security policy? You give it the name, you put the direction, the IP address, the service that is involved, and the action has to be permitted. Okay, so source NAT using the commands, how do you do it? You go into the user view, okay, you configure NAT, the NAT pool, so this is NAT address, and then you give it the number here, and then the section, this is the range of the addresses in the pool. How do you configure the NAT policy? You start with the command NAT policy, rule name, you give it the name, source zone, trust zone, and then here you put the action NAT, which in fact you get this from the NAT pool. Okay. How about configuring the web and FTP servers? Okay, so this is NAT server now. So with NAT server, you start with NAT server, the name, the protocol which is involved is TCP, the global address, which is the public address, this one. Web is what? Port 80. So very, very important that you know the web port numbers. And then inside, okay, 880. And then for NAT, and then for FTP, NAT server, the name, the protocol, FTP inside, and then FTP. And then the policies, security policy, rule name, you give it the name, okay, source zone and trust destination. Of course, this one, it goes to the DMZ. Remember, when we have the servers and we want someone to be accessing them, we put them in the DMZ, the destination network. The service type here, this is web, so the protocol which is involved is HTTP, and then action permit. For FTP, it has to start as security policy, rule name, then source zone and trust. Destination is DMZ. This is the destination address. The service here, we're dealing with FTP, and the action here we have to permit. Okay, so that is that for today. Now we go to the the questions that you have to ask. So let me unmute all of you so that you can be able to ask the questions. All right, is it possible? I think maybe you have unmuted yourselves. Is it possible that you can unmute so that you'll be able to ask questions? So those with questions, you can unmute. I'll start. Hello, are we there?
Yes, sir, we're here.
Yes, we are here.
We are here.
You are there. That's good. That's good. All right. So I'm going to start with lecture 1. I'll be going slide by slide. Are you seeing the slide, isn't it?
Yes.
Yes.
All right. So any questions here? Do we have questions? On risks? Let me go to the other one. So this is our second lecture. Do you have questions on this slide? You know, you have to feel free. You are in class.
Mr. Teo, I've got a question.
Yes.
Which one comes first between ISO 2701 or ISO 2702? When it comes to planning an information system.
Yes, the one which comes first is 27,001. It is the one having the requirements. Okay.
Okay, then you go on to the second one.
Yes.
Okay. All right.
Yeah. So I hope you know this is very, very important because these are the documents you must follow in your organization when implementing what? Security.
Yes.
Okay.
Mr. Teo, another question.
Yes.
What is the difference between the ISO and the ISM? You can go back to the previous.
Okay. Here.
Yes, and the different. Yeah. Yes, this one. ISM,
Okay.
ISMS, and ISO.
All right. So you see, ISMS, it got some of the things from ISO 27,001. So ISMS has that, plan, do, check what, and act, which
Yes.
ISO does not what? Does not have. Are you getting what I'm saying? Yeah, that's how different they are. But this came from here. But it has got its own things, how it does things. Okay.
So I've got a question on the previous slide.
Okay. This one?
The other one. No, the other one.
Here?
The one which is saying graded protection. I think it's forward. You have missed it somewhere.
Okay. Graded protection of information security.
Yes. Yeah, now the next slide, yeah.
This
yes,
one?
just here.
Okay.
Yes, I wanted to find out, is this one globally recognized or just maybe for the Chinese?
Yeah, good. This is in China.
Okay.
The Chinese do it, okay? Yeah, but this is very, very important because, I mean, the government takes charge of what is happening, you know, to make sure that the information of citizens, these organizations, they are handling it well. You know, the government has to be involved. Okay, are you getting it?
Yes, sir.
So all this is there to avoid data breaches. Okay, so if the government is fully involved, then these organizations, they will make sure that they protect the information of the people. Okay.
Okay. So does it mean that,
pardon?
Say, does it mean that, say, country Zambia, say we implement some Huawei devices and maybe routing standard and the security standards for Huawei, do we get these security standards in terms of the graded protection of information? Do we get the one for China? Maybe we form our own. here.
Zambia ought to have its own. Okay.
Okay.
We must do this, but I know they have done something. I mean, cyber laws, I think they're in parliament, like something like that anyway. I don't know whether they were passed or not. Mr. Mooney?
Yes, Mr. Teo, no, that one was passed, sir.
Oh, they moved from parliament?
Yes, it was passed in 2018, I think.
Oh, okay. Oh, that's good. Oh, that's good.
Yes. Let me just locate it. I'll share it on the group.
Okay, okay. Thank you, Mr. Mooney.
Yes, sir.
Okay, fine. Okay. Okay, so these are the other standards that are there. So this was our slide number 2. We'll move on to slide number 3. Okay, do we have questions here? I'll be going slide by slide. If you have got a question, you say it, okay? Where you didn't understand. Quintuple, this is common network protocols that we have. ERP, ICMP, Tracent, routing protocol overview, OSPF, one of the dynamic protocols, SNMP, the protocol that you can use to manage your network. Okay. We'll go to common network devices. So here we have a switch.
I'm Mr. Teo on the switch.
Okay, on the switch.
Yeah, you mentioned that we have 2 types of switches, the one that can run on the second layer and another one on the third layer. Yeah, on the third layer.
Good.
Sometimes we call it a managed switch. So now on the documentation, we said this one is forwarding a MAC address for those who are in yeah. So now I'm wondering, what about those which is on the third layer?
All right, so that one was talking about the modes in which the firewall can work.
Okay.
Okay, so the firewall can work in the mode of a layer 2 device. Now,
okay.
when it is working in a layer in the mode of a layer 2 device, it means that there what we are using are the frames, isn't it?
Yes.
Yeah. Now, when it's working in the mode as in the other mode as a router.
Yeah.
I mean, as a layer 3 device.
Layer 3, yes.
It will be dealing with the packets.
Okay. Okay.
Yeah. So now, when the firewall is working in that mode, that's when it can work with other devices as well, like the UTM, the intrusion prevention system, because they're dealing with packets. Are you getting it?
Okay.
Yeah,
yes.
Very, very important that you are following, sir. I'm happy.
All right.
Okay. Okay. So VRP, this is Huawei Network Operating System. We'll be doing this in the lab, which will be in our last lecture. Okay. Common. This is common information security threats. Okay. Do we have questions here? Stuxnet. Security threats categories. DDoS attack. Mirai. Scanning. Weibo. Phishing. Man in the middle attack. So I find that there are tools which are used in this man in the middle attack. We go to the other module, second module. Do you have questions? Operating system overview. Windows, Linux. So I said, be efficient in Linux because security tools, they are Linux. Even the best operating systems that we use in ethical hacking or what is called pen testing, we have Kali Linux there with so many. Though it was made for pen testers, hackers are using it to hack our institutions. So you see, oh, anyway, I wanted to, you are not there. Okay, I'll reserve for some other time. You are not on that platform. which has Linux, Linux for free and so on. Okay. Oh. Yeah, I'll talk about that later, not here. On our WhatsApp group. Yeah, now this topic, common server types and threats. Servers. Different types of servers. Server security threats. Types of scanning.
Mr. Teo, I've got a question on the server. Huh?
Okay, fine, good. Where exactly?
Yeah, you said on the processing capability of the servers. I saw something like 86. Why is it 86 rather than 64?
Oh, it was talking about the architecture.
Yes, the architecture, yes.
Yeah. Oh, you talk about...
here, that's it.
Yeah. Anyway, this is how it is labeled. Of course, this is a computer architecture language.
Okay.
Yeah, this is the language. Yeah, so sometimes they don't put even 64 and 32. They would use this computer architecture.
Okay.
Yeah, so we talk about 32-bit architecture, 64-bit architecture, but yeah, that's how it is. Yeah.
All right.
Yeah. Okay. Okay. Then we go to host firewalls and antivirus software. Firewall classification. So this is what we have on Windows. Make sure you must know it. This is the IP tables, antivirus.
Wait, not now.
Okay. So we'll go to the third, which is introduction to firewalls. Do we have questions here?
Let me give you.
Do we have questions
Let me
here?
give you.
Okay. And the last slide, which is NAT, Network Address Translation. I did explain here that we were running out of IPv4 addresses. And of course, they came up with IPv6 addresses, but we couldn't replace IPv4 immediately. It has to be a process. Therefore, came up with NAT, which allows IP addresses to be used. That is the same IP address to be used by so many organizations. And these are private addresses.
I have a question.
Yes. Go ahead.
About the IPv4, I didn't understand it clearly on the IPv4 address. Like, can you explain it a bit more?
Oh yeah, all right, okay. So when they were coming up with the internet, there was IPv4 with 32 bits. So from 32 bits, we get about 4 billion addresses. And what you must know is that for a device to connect on the internet, it must have a unique IP address. So now, more devices were being added to the internet. Therefore, we were running out of IPv4 addresses. 4 billion, not a big number. Are you getting it, madam?
Yes, I'm getting.
Yeah, so we were running out of IPv4 addresses, but someone came up with IPv6 address. IPv6, they have 128 bits, and that gives us trillions and trillions of addresses. Now, we could replace IPv4 immediately with IPv6 because so many organizations are using them. So there's need for a process, for a transition from IPv4 to IPv6. So currently, IPv4 and IPv6, they are working together. But in future, we are going to remain with only IPv6. And the question arises, are we going to run out of these IPv6 addresses? That's the question we need to answer because we have trillions and trillions of them.
Good question, sir.
Yeah, so now, you see, because the IPv4 addresses couldn't be replaced, somebody came up with an idea of NAT. So with NAT, here we have got what are known as public addresses. So UNZA internally can be using the same addresses as in so many organizations. But a PC at UNZA, if it wants to go to the internet, it has to be NATed. It has to be assigned a public address. So NAT at least increased the IP addresses in that the same IP address can be used by so many organizations. Yes, Watson?
Yeah, yes, sir. I just needed clarity. Like their organizations, I think it's on firewall. This is antiviruses, Yeah. Now, is it proper in an organization whereby you're using a same firewall? I think if it's a manufacturer and it's also the same company which is supplying you with the same antivirus. I don't know. Is
Yeah, I got
that,
I got it.
Yes, sir.
Yeah. On that one, I got it. Yeah. So you see, what we need to do in the organization is to use different devices from different manufacturers. Are you getting it? Huh? So the Huawei
Yes, sir.
firewall can accept the viruses from different companies. Are you getting it?
Yes, sir.
Yeah, that's how it is. So you can have, let's say, a firewall from Huawei, but an intrusion prevention system, which is a standalone system also, maybe it can be from HP and so on. That's how you do it. So that when hackers are able to pass through the Huawei firewall, they can have challenges passing through the intrusion prevention system from HP. Yeah, so, yeah, what we are doing now is that the very firewall can have inside it, as well as an intrusion prevention system inside it. Of course, it has to be from Huawei, okay? As well as other content filtering, systems inside it. The devices now are able to handle such large amount of technologies within them without having any problems at all. Otherwise, it was an issue, a performance issue. I hope that is clear.
Yeah, very clear, sir.
Okay, fine. Do we have questions on NAT categories? Source NAT, easy, IP, NAT, ALG, server mapping. This is the application of NAT. All right, I think that is that for today. Thanks very much for attending. So the thing is, we are going to meet again next week on Monday. So we'll meet next week on Monday, Tuesday, and we are going to finish on Wednesday. So on Wednesday, we are going to do the labs, right? Anyway, good night.
Good night.
Thank you, sir. Good night.
All right,
Good night.